Hello guys. Hey there. Welcome back. It's been some stressful weeks. I live in Venezuela and we have a massive earthquake. So yeah, it's been stressful. Me and my family are safe, but yeah, still was pretty tough to get back to streaming. But I'm back to streaming now, and there are many things that I want to start off, and there are several things I just want to get going, and try to just remind what we did so far and what can we do to improve. So perhaps let me show you where we at, or maybe let's just remind ourselves where we at and what we are trying to do. So this is a YouTube series in which I'm going to develop a LLM from scratch using ROS. And the cool part about this is I don't have any experience in ROS. Everything that we are doing, I'm learning on live with you guys. So yeah, bear with me in many things if you already know ROS. Just be patient because I don't know anything about ROS until whatever we learn here. And the rule is that we are not going to use AI to build this, because if we ask AI to do it, it will be just simple, and it doesn't make any sense to just get roll with that. But the important thing is that we wanted to create a mental framework for us to learn and to develop intuition on how a LLM actually works and the different pieces that we need to put together. So that's what we are trying to do here. And let's just remind ourselves what we did. So we start, this is the main functionality, and so we start to importing a file that we already have in our environment, and this file is a bunch of text, and from that text we would just want to count the characters. We want to use those characters to create a regular expression mechanism so we can kind of split. So we are doing the first part of an LLM, which is, yeah, so which is the tokenizer. So we want to convert letters or words into tokens, and those tokens is the way we are going to feed to the LLM, right? So that's what we are doing here. We just use regular expression to see where we want to separate things. We create a vector of a string, which if you already know Python is kind of like a list of strings. Then we filter, and then we print what we have in this place, and then we count the number of tokens that we have in our file. And yeah, so that's essentially what we are doing in this part. And then we want to map out the number with the ID. So let me show you what can we do here. So it's this not it. So I think it's Ross cargo run or something. It's cargo run, I think. Yeah. Okay, so we start with an error. Did we have this error last time we checked? I don't know if we had this error per se, right? Where is the error come from? Let me see. And it's weird because I'm pretty sure we solved a lot of this stuff in the previous live streaming, but it looks like we didn't. Okay, so I just run and sets expected identifier found keyword 4. So it will be the simple tokenizer. Yeah, because the other thing that we did is that we create a struct, which is, for those that doesn't know, is kind of like the class of Python, but it's not the same thing. It works similarly, because you create a template, and that template you can reuse it, and that's essentially how the Python classes work. But in Rust you don't have object oriented programming per se, and we do have a video explaining that in the channel, so please check that out. But yeah, I mean, I think the error is around here, right? But why is it wrong? Why is it wrong? I don't know. Okay, for key value in vocab. Okay, expected identifier found keyword. Yeah, because this is a simple token. Okay, so let me try to go back and understand what we are doing here. So you see, this is what Sebastian suggests. So for us to use, this is a simple tokenizer, and from that token, this is in Python. So from that tokenizer, we create a vocabulary, and then we pass into integer to string, right? So for that, we need to iterate. Essentially, we have the integer number 1, 2, 3, 4, 5, and we pass a string for that, and it can be word, it can be anything that we want. And then we have the encoder. The encoder is the one that processes from text into numbers or integers in this case, and the decoder is that what it does the other way around. So okay, so we started with the template as string to integer and integer to string, which is exactly what we have here, right? And okay, so since this vocabulary is a dictionary and this is also a dictionary, so what we want is that we have the dictionary and we want to pass the string into the integer, and this is the integer to string. So it's a bit3 map here in Rust, right? And this, it kind of works like a method, right? Like this type of method, but we use the simple tokenizer, the class, and then we create a public function. Okay, so this public function doesn't have a name. It should be the decoder, but I don't know if it doesn't have a name. Weird. I don't know. This is the encoder. This is the decoder. It looks like I did everything here. Maybe. Yeah, yeah. Maybe I missed something when we were working on this stuff. But yeah. Okay, so let me try to think. So okay, I did career run. What was the last time that I used this stuff? Okay, yeah, because yeah, I did use this because we have some mismatch, and I couldn't figure out why we have those mismatch, but we have it. So I did use AI to try to understand where was that. Let me see the expected identifier, right? The expected identifier found keyword is what we saying is what we have here. Expected identifier found keyword. But why it says should I use this? Exactly what this is saying. Let me see. I don't think that will work at all. Yeah. One cool feature that we could use AI is to understand where we at and what's wrong. So, okay, use the code to help me to identify what am I doing wrong and what's the status of this project without giving away the answer. Yeah, I mean, I think we can use some because I don't want to get blocked into this. So one thing that we need to keep in mind is that AI helps a lot to unblock yourself, but you shouldn't delegate the thinking process to AI. That's essentially where I want to go, or the place I want to use in this live streaming is I want you to think for yourself, and I want that everyone can start to put our minds into it and kind of go back to 2015 when we use only a Stack Overflow, but now we have a mentor that can help us without giving away the answer. So let's say what it says. Your project is a ROS port of a Python-based text tokenizer. Exactly. Following simple tokenizer following a workflow typical for LLM data is processing, which is reading raw text, regex splitting, building a unique vocabulary map, and encoding the coding text into token ID. Exactly. You have built the core processing pipeline in ROS, yeah. But the execution is currently blocked at compilation due to syntax structure issues and ROS type system rules. Yeah, that's exactly what we're seeing here. So what you are doing wrong, guided hints, struct literal syntax versus imperative statements. Okay. Sounds confusing. In ROS, struct initialization block is fill val. Okay. Oh, yeah. Yeah, I think this should be close, right? You cannot execute control flow statements like a for loop directly inside the struct literally. Hint, prepare your local variables and populate your collections before building and returning the struct instance. Yeah. Is that what they are saying here? That we should do something like this? Let's see. No, it's exactly the same error. Well, not exactly the same error, but you get the idea. Let me show you. Yeah, let me show you. I should remove this. Another. I don't know. Okay, but let's see. So the error that I'm having here is that I already have the string to integer vocabulary, and that maps to the vocabulary, but then the integer to string I don't have it here. I was trying to put it in here, but it doesn't work. Why I put these out? Maybe that's the error, right? Maybe it's because I didn't initialize. Yeah, I think that is the issue. No, good. Okay, let's see, it doesn't have. Okay, but this is another error, so I think we move past this. Then it says the size for values of type string. Okay, the issue here is that I wasn't initializing the integer to string, and so I only have the string to integer and it was mapped to the vocabulary, but I also need to have the integer to string. So that's what I put it here. I put integer to string, and then I started to insert everything that I have in the vocabulary, and then I match value with key, right? So yeah, that's what I did. But now I have another error, and this error came from 82, yeah, here, from the decoder part. Okay, so the decoder part doesn't have a size, no a compile time. So the error is here. No method name concat found for struct. Okay, so I cannot do this. Oh yeah, and this is still an error. Let's see what we have here. Okay, so this says that a rows, the way you initialize a struct block is that you have the field and the value, and it's kind of like a dictionary in Python. So you move into that part, and it's strictly an expression expecting field value pairs. So you cannot control flow statements like a for loop directly inside the struct literally. Yeah, literal. Yeah, so that's what I was trying to do here, but it turns out that I can't, or I shouldn't, right? So here, prepare your local models and populate your loop collections before building and returning the struct instance. Maybe, maybe if I put it here, the new one, maybe that could work. Maybe that could work. Maybe I can do this. No, turns out I can. Maybe if I put it this, I'm making things up. Yeah, but that's what I wanted to show you guys. I mean, you don't have to get the right answer right away, and you can start to debug and try to go over several stuff, because that's what it creates the learning. So the learning is not a straight line, it's more like a batch, or like a curve that where the learning curve that you go up and then you go down, and you start to move around different things until you master, or you create mental framework that helps you to solve these type of issues in the long run. But yeah, it says that I cannot do this. And so okay, so storing on size type strings versus the string. Okay, yeah, I think this is one of the consequences of having several weeks away from the keyboard and away from this live streaming, that I don't really have an intuition where we at last time. Yeah, maybe I need to watch my last live streaming and see what we're wrong and why we have so many errors. I didn't remember this kind of errors. I thought we have some concrete, but maybe I messed up a few things trying to create the code bar. Okay, so what's happening? The compiler notes doesn't have a size nor a compile time for string. In Rust, string is an on-size slide type. Collections like B-tree map and B require elements that implement the size thread, so their memory allocation size is known in the compile time. So yeah, the issue here is that in this exact line of code, the issue is that we don't know the size of the vector, and Rust required to have the size of the vector. Consider whether your map values should be string slides with a lifetime bound, or on a string. Additionally, examine whether key types should be plain integers. Yeah, but I think so. But should I put inside here or where? I mean, there are so many issues, man. Yeah, yeah, it's kind of exhausting when you have a lot of issues because you don't really know where we are. Yeah, I feel tempted to just ask AI, but I don't want to do that. Yeah, no, I don't want to do that. Hmm. Yeah, I'm thinking, how can we solve this issue? I don't know. Okay, so I have the simple tokenizer, then create a new function, it's a public function that initialize everything. Yeah. Yeah, most likely, most likely. Yeah, because I really don't know what's going on, to be honest. Okay, this is what we can do. Let's start to, so we already initialized the simple tokenizer. We have the string to integer, the integer to string. Okay, that's good. This is the way we implement the struct, or we create the methods, kinda. So we have the public function, then we have the simple tokenizer. This clearly is not the right answer, right, or the correct answer. Yeah, I need to. Can you please give me the solution for the simple tokenizer implementation? Yeah, because I don't really know what's going on. I do want to understand the explanation, but I don't know what's wrong with this. Yeah, yeah, and I perhaps it's because I don't have the continuity that I had before. Why you are asking this permission in the first place? No, I don't want that. You already know. Just give me the answer. Yeah, because the AI wants to. Oh no, man! Why you do that? Maybe I need to constrain. Cursor has. But let's try to understand what's suggesting here. Because it's different, man. Okay, let me try to understand what is saying here. So the first thing he wants to change is the simple tokenizer. So integer to string will be a B3 map, which it already is. Okay, but then instead of only, so in why is that? Why this A? But it looks exactly the same, right? As the one that I have, the string to integer. So it's weird that I didn't have before, because it is a string and a string. Okay, so this was messed up. Okay, yeah, that makes sense. Okay, so it's implementing this right here. let integer to string, so b3 map new. Okay, this is what I did here, b3 map new. Then for okay, I need to put these values. Okay, invoke up value key, so it's really similar. I need to take it. Okay, yeah, and then integer to string. Yeah, so we initialize before, and then we after we initialize the integer to string and string to integer is where we actually put it into. Oh no, yeah, I mean he's initializing even before, because the integer to string is already the b3 map, and I iterate and pass everything into this. But this, I think this indicates that I want to access to the key and to the value, and then I have the simple tokenizer in the string to integer, which is the vocabulary, and then into string, yeah, which I already passed right here. Okay, empty space, so this is not an empty space, but it says that I don't need it. I guess it's because it's already a raw text. Okay, process vector to string is exactly the same as split keep, which is the one that I define here. And it's, yeah, exactly the same. It's just raw text and I'm accessing into that. Okay, makes sense. Okay, so in the decoder part it has a lot of suggestions, so it's changing everything. So let mood words, so he's not putting mood, we are putting let words plural, and this will be a vector of a string, and it will be IDs. Then we iterate over the IDs, or yeah, we iterate over the IDs. Then we filter by the yeah, I'm replacing this. Yeah, we filter, then we collect. Makes sense because what I'm doing here is I'm iterating, but I just want to grab the value. Is a vector, right? So the vector doesn't store key value pairs, it only stores a single type of elements. So it can be it's kind of like a list of strings, a list of integers. So it's essentially the same here in ROS, and I'm not storing the whole dictionary, which we already have that match key value pairs. We only get the values or the words or the each individual word in this case, and then we join all those words, which I didn't do here. I did use the unwrap. Then I create a regular expression, which is exactly the same that we have here. I think it's exactly the same. Yeah, so and then we replace all text. Okay, I mean I think it makes sense. Okay, so this was an error. Okay, it should work. Let's bet that this works. Okay, this is actually working. Yeah. Okay, let's go to the Sebastian repository to see, because this is what we are using. So okay, we are at this stage when we are processing the data for the pre-training phase that we want to build the LLM. So we are just sampling and creating the tokenizer, and with this, yeah, we're embeddings, tokenizing text. We already passed this because we already have this imported into our file, which is embedded.txt, right? Then we count the number of characters which match what we have here. We match the number of characters, all this stuff. Yeah, we are doing the same thing. Then we create a vector. Here Sebastian is creating a vector, and from this vector is processing the same way we are doing here. We calculate the number of token and match what we have here. they convert the token to the IDs. This is what's happening. We have an input token, and from those input tokens we split those tokens, and so we have a raw text, and from that raw text we split into words, and those words are mapped out to IDs that are the token ID that we want. And in this case we are just doing by order, so the first word in our vocabulary will be zero, and so on until everything that happen. We are removing duplicates. Yeah. And the vocabulary size is 1130. That's autoorganizer. Then we print this. Yeah, we validate the key match pair, which is essentially what we are doing here. Exactly the same. Okay, then we put a simple tokenizer together. Yeah, because with a simple tokenizer, now that we already have the simple tokenizer, it's a lot easier because you can import the simple tokenizer, we create a new one, and we have the vocabulary. And remember that the vocabulary is a key value pair, right? Key value pair that we created. We have the words and we have the IDs. But we pass a complete set of different texts, and we want the IDs from these random text that we find online, and it's exactly what we have here. We are encoding, and then we are using the decoder, which is encoding, decoding. Yeah, pretty cool, right? I really like this. Okay, adding special. Okay, so this is 2.4. Adding special context tokens. It's useful to add some special tokens for unknown words and to denote the end of a text. Yeah, so yeah, I mean, we mentioned that LLMs need a lot of context and need to understand where they are in terms of having enough information to tell you where you at or what you want about individual text, right? So when you pass a bunch of text, you don't really know where's the beginning, where's the end, where's the middle. You don't have that type of context. You only have words into your system, and from those systems you map out with numbers, and those numbers what you ask. But there are special tokens that allows to create context. For example, there are tokens that can signal this is the beginning of a text, this is the end of a text, this is the beginning of a sentence, this is the end of a sentence, or this is the middle. Like, there are many things that you can do with those special tokens to tell you exactly what, or to give you context to your LLM. So that's what we are going to do in the next session. In the next session, we are going to pass out these special tokens to enrich the context of our LLM. We already get a lot of great stuff. We are just trying to get into shape and to speed up our implementation process. But at least we already have the code and the code part, and it looks pretty cool because now it is a kind of like a class the way Sebastian have it. We just need to pass out or pass into it the more context to improve the understanding of the text. Okay, so yeah, I think that's it for now. Thank you so much, guys, and we will be seeing you more frequently with this YouTube series, and we are going to try to get more things done And one thing that I do want you to take out from this session is that there are many things that you can do to learn, and learning from scratch and trying to put your piece together and try to get that feeling of uncomfortable learning when you struggle a lot to find a solution and you don't really know what to find, and eventually you ask AI when to unblock yourself. That's where the most learning came from, and you have the best tutor in the world by just having the AI answer your questions to the specific things that you need. So I think that's really valuable, and that's a skill to master. Okay, so yeah, thank you so much, guys, and I see you guys next session. That will be tomorrow. And yeah, just keep practicing, try to learn some raw. See, you can help me here in the chat to understand more about ROS and building an LLM from scratch, and hopefully we can get our first LLM really soon, and we can, just release. It's supposed to be more efficient, we don't know yet, but hopefully it will. So okay, thank you so much, guys. Take care. Bye.